Greetings. Today we are going to discuss the next part as the remaining part of the measure of central tendency. I hope that I am properly audible. Okay. Last time we have seen different measures of central tendency as arithmetic mean, geometric mean, harmonic mean, and also median. Now we are going to see after this, that is mode. And for every, we have discussed the merits as well as demerits. Mode. Mode is the value that appears the largest number of times in a given data. The most repeated value or that value which has maximum frequency. Suppose we have a data set in which there are only 6 observations as 2, 4, 5, 5, 6 and 7. The mode of this data is 5. You can find arithmetic mean also, geometric mean also, median also, and mode. So mode is 5 because it is occurring twice and all the observations are occurring less than 2. Find the mode of the given data set 3, 3, 6, 9, 15, 15, 15, 27, 27, 37, 48. So there is no absolutely any necessity of any calculations or manipulations. You can directly say that the mode of this data is 15 as it is their maximum number of times. So that is fine. Whenever we have raw data, then it becomes convenient to us. We have to sort in either ascending or descending order, and we can just have a look at a glance and you can immediately come to the conclusion about the value of the mode. Okay, that was fine. Then if we have frequency distribution, so in that case, how to find mode? That is the problem. So here I'm going to do a formula. We have been given frequency distribution, and then what is the mode? Suppose there are class intervals, there are simple frequencies, class interval frequencies as such. So the formula for mode is equal to L plus Fm minus F1 divided by 2 times Fm minus F1 minus F2, and the whole thing is multiplied with H. So L is lower limit of the model class. Now how to identify the model class? We have to see the column of frequencies. You have to identify for the maximum frequency, and the corresponding class interval is going to be the model class interval. Then small fm, small f means simple frequency, so frequency of model class. F1 frequency of pre-modal class, F2 frequency of post-modal class, H width of modal class. So this is the formula, and let us see, find mode for the following data. So class interval frequency, we need not have to construct any more column, and here we see frequencies as 2, 12, 22, 8, and 6. So I think you see 14 plus 6, 20 plus 50, capital N is equal to 50. That is, this is the data of 50 observations which has been distributed into 5 classes. Small f is simple frequency. Okay. And now we see the maximum frequency is 22. So I can say that modal class is equal to 20 to 30. And now mode is equal to L plus Fm minus F1 divided by 2 times Fm minus F1 minus F2 into H, and this is equal to 20 plus frequency of the modal class is 22 minus frequency of pre-modal class 12 divided by 2 times frequency of the modal class minus frequency of pre-modal class minus frequency of post-modal class into the width. Width is 30 minus 20, that is 10. So as such, we can solve this and we'll be getting the answer. So just try to make use of the calculator. So here, if I use calculator from my mobile, then also I'm going to get the answer. So denominator is 44 minus 20, that is 22. Numerator is 22 minus 12, that is 10. 100 divided by 22. 100 divided by 22. And plus 20. And the answer is equal to 20.5454 like that. So I can say 20.5 is the mode of this data. And one more thing, even though it is not told, we have made an explicit formula to evaluate the mode, and here I'll be finding mode by graphical method also. And for that we have to draw a graph, and you have to tell me what the name of the graph is. So here class interval will be along x-axis 0, 10, 20, 30, 40, and 50 as such. And along y-axis there will be frequency small fi. So we can see maximum is 22, so I can say this is 5, 10, 15, 20. So this is totally free sketch. Class interval 0 to 10 class, and frequencies 10 to 20, 12. 20 to 30 is 22. 30 to 40 is 8. 40 to 50 is 6. And you know that the area of each rectangle is proportional to the relative frequency. Relative frequency means the frequency divided by total. So 2 upon 50 as to 12 upon 50 as to 22 upon 50 as to 8 upon 50 as to 6 upon 50 as such. Or you can say the area of each rectangle, there are 5 rectangles and the area is proportional to 2 as to 12 as to 22 as to 8 as to 6, and the name of this is histogram. And how to find the mode graphically? So you have to go for the tallest column. In that, see the extremes. We have to join these two lines. This 2 points by a straight line and another 2 points by a straight line, and this whatever is the point of intersection, from that point you have to draw a line parallel to y-axis. As soon as it touches, the x value is going to be the mode. So it may be, suppose, very close to I think my answer is mode. Mode, let me modify. The mode is 24.555. So 20 plus the remaining expression is 4.55. Okay, so it was 24.55. And here mode graphically is coming around 24.5, something like that. If you are trying correctly, making use of the graph paper, you are going to be very close to the accurate figure. Okay, so this was all about mode. What are merits and demerits of mode? A mode is the most representation value of the distribution, as the definition tells. It is not affected by extreme items in the series. Or we can say, let's suppose there are 100 observations in a data, and we know that we have to see that value which has maximum frequency. Even if you change the initial values or the last values, then that is not going to affect the value of the mode. Mode can be calculated for open end classes also. Yes, absolutely. Even if the first class is like this, up to 10, our last class interval is 50 and above, still you can find mode. It really doesn't matter. It can be located by inspection. In the first 2 examples we have seen, as soon as we see, we can tell about. Then demerit is, it is not based on all the observations. Yes, it is not capable of further algebraic or mathematical treatment. As seen, we have already seen. Suppose there is arithmetic mean, then the combined mean can be also found like that. Then using mean we can find variance, standard deviation. So many manipulations can be done on arithmetic mean, but that is not possible with mode. Mode is not rigidly defined because there are several formulae of the same, and mode is ill-defined. That is another disadvantage. It is not always possible to find clearly mode. So nobody has come a question in mind. Suppose in a data there are 2 values which are appearing maximum number of times. Then what will it? Yes, both the values will be the mode, and in that case, that distribution will be called as a bimodal distribution. Yes, some distributions or data may have 2 values of mode, even 3 values, 3, 4 also. So 3 and above is called as a multimodal data or multimodal distribution. Now, from this, let us switch to the measures of dispersion. So, but why the necessity is coming into the picture about to learn measures of dispersion? For that, I would like to explain in my regular way. See, we have studied measures of central tendency as arithmetic mean, geometric mean, harmonic mean, median, mode. Still, even if we learn all this and apply, then we cannot understand the given data completely. How? Let us try to understand. Suppose there are two batsmen, then who is better batsman? So if I ask you what is the criteria to call a batsman as a good batsman, then somebody will be saying that a good strike rate, somebody will be saying that a consistency, somebody will be saying average. So let us, the first part is average. Average of the batsman should be good. And we know average means it is arithmetic mean. As long as cricket is concerned, see, also meaning a batsman may be not out. So even if a batsman has played 10 number of matches on out of which the batsman might have got chance to play in bat in 8 matches, and suppose whatever the runs he has scored is 200, but out of 8 matches he batted, he got out 5 times. So 200 upon 540 will be the average. That is simple. Now, suppose there are two batsmen and their scores in the latest 3 matches are like this. The first batsman is we score 50, 50, 50, and another batsman has scores 100, 0, and 50. Now, if we see that average, average is a very good criteria to judge whether a batsman is good or not. If we find the average of the first batsman, it is coming as 50, and the second batsman has also average 50, 150 upon 3. So from this we realize that there may be two or more than two data sets, even if the individual observations are different. And further you can extend that number of observations are also different, still their arithmetic mean can be the same. So this is one little property to be noted. And thus this tells us that just learning measures of central tendency or averages is not going to help us to understand the data completely. So we have to learn measures of dispersion also. And what is dispersion? Dispersion is variation. Variation of individual observations in a data from their average values, scatteredness, dispersion. So dispersion is the extent uh, to which the values in data differ from the average value of the data. So this is dispersion, and I'm going to discuss some very important measures of discussion in the remaining part of this session. And here, every time we are going to derive new. Actually, during the class, I used to ask anyone at any time, but it is not possible here practically, because even if I ask, it is not guaranteed that the fellow will be unmuting. Now, a measure of dispersion will be either absolute or relative. Absolute if it has a certain unit, kilogram, centimeter, something like that, then that measure is called as an absolute measure. A measure of dispersion is relative if it does not have any unit. So every time whenever we learn a particular measure of dispersion, we'll be curious to understand whether it is an absolute measure or a relative measure. And the simplest I'm going to start with is range, and it is maximum value minus minimum value. And you can understand that if the individual observation in a data set has unit kilogram, then maximum value will have unit kilogram minus minimum value will also have unit kilogram. Suppose 100 kilogram is maximum value, 40 kilogram is minimum value, then 100 kilogram minus 40 kilogram is equal to 60 kilogram. It has some unit and hence it is an obsolete measure. Obsolete measure. Now the second is coefficient of range. The formula is maximum value minus minimum value divided by maximum value plus minimum value, and we can understand here as in regard to the previous example, suppose maximum value is 100 kilogram, minimum value is 40 kilograms. So in that case 100 kilogram minus 40 kilogram, sorry, in denominator there is plus, then the numerator will be 60 kilogram and denominator will be 100 kilogram plus 40 kilogram, 140 kilogram. So that is 60 upon 140 kilogram will cancel, and this is a relative measure of dispersion. This is a relative measure. Okay. Now, these are very simple and comparatively less useful. The third measure after this is, before writing that, I would like to ask you, suppose we have primary data in which there are only 5 observations. 5 observations are there. And accordingly, suppose 9, 1, 7, 8, and 5. These are the observations. These are a simple 5 observations. Now, what is x bar of this? X bar is equal to, in this case, we know that as summation xi from 1 to n upon n. So this is 10 plus 50, and lastly add up to 20. So this is 30. 30 upon 5, and that is equal to 6. 6 is the arithmetic mean of this data. Now we have to consider the deviation from the arithmetic mean, xi minus x bar. And I am going to find out, and let me write the total. I am going to write total directly. See, I have written it as 0. Now, you can do it anything. You can consider any type of data and you can blindly write summation of xi minus x bar is equal to 0. This is really absolutely not a magic. This is very simple. This is raw data summation of xi minus x bar I running from 1 to n, and that is equal to summation of xi I running from 1 to n minus summation of x bar I running from 1 to n. Now summation xi means sum of all the observations, and as we have seen x bar equal to summation xi upon n. So summation xi is equal to n times x bar, means number of observations into arithmetic mean. Minus x bar is constant, and this is summation of, you will be wondering that this is very simple. What shall I write inside? This is 1. Only 1. And really next one is even interesting. What that? Summation 1 I from 1 to n, that is 1 plus 1 plus 1 n times, and that is equal to n. So it is not 1 plus 2 until n, because it is not summation I from 1 to n, it is summation 1 I from 1 to n. So you have to go on putting different values of y. Every time the value of the term will be 1. So 1 plus 1 plus 1 n times, and that is equal to n. And thus this is summation xi minus x bar is equal to 0. You can see 9 minus 6 is equal to 3. 3 minus 6 is equal to sorry, 1 minus 6 is equal to minus 5, 7 minus 6 is equal to 1, 8 minus 6 is equal to 2, and 5 minus 6 is equal to minus 1. So this 1 and minus 1 cancels, and remaining 3 plus 2 and minus 5, this is 0. So you can consider any number of observations in that raw data and consider find xi minus x bar and add, it will be 0. It is quite possible that x bar may not be integer, still that is going to be summation is going to be 0. So that is the problem. So what we were expecting, we are designing a new measure of dispersion, and in that we have seen we were trying to get summation of xi minus x bar, but it is coming as 0. The reason is some values of xi minus x bar are positive, some are negative, and remaining might be 0. So those are going to nullify each other. So this is of no use. So what is the remedy? What is the improvement so that there will not be any negative value? So obviously somebody will be telling consider absolute value of xi minus x bar. So this is difference between 9 and 6 is 3, difference between 1 and 6 is 5, difference between 7 and 6 is 1, difference between 8 and 6 is 2, difference between 5 and 6 is 1 as such. So these are the differences. So this is also called as deviation of individual observation as xi from its arithmetic mean, and we have to take average of this. So we know that for taking average we have to add all this. 3 plus 5, that is 8, plus 1 9, 9 plus 2 11, plus 1 12. So 12 upon 5, and that will be equal to 2.4. and what is this? This is nothing but what we have done, summation absolute value of xi minus x bar I running from 1 to n divided by n. So this is arithmetic mean of deviations of individual observations from their arithmetic mean, and that is called as mean deviation about mean. So here I am giving the formula for raw data as 1 upon n summation I from 1 to n absolute value of xi minus x bar. And for group data, the formula will be, now you can understand that if there would have been some group data as xi, then fi, so we have to find x bar as 1 upon n summation of fi into xi, I running from 1 to k. So next column has to be xi minus x bar, but that has to be multiplied with fi. And moreover, if we get summation, that will be 0. So what we have to do? We have to take absolute value. So the formula in case of group data is going to be absolute value of xi minus x bar, that is multiplied by fi summation I from 1 to k, and that is divided by capital N equal to summation of small fi running from 1 to k. Okay, so in this formula, if instead of the absolute value if we just put bracket, then this will be 0. Summation fi times xi minus x bar for group data will be 0. Now this is mean deviation about mean. My next question is it relative or absolute? Suppose original observations are in kilogram, then absolute value of xi minus x bar, everything will be in kg, and then total will be 12 kg upon 5. 5 is in at less quantity, so it will be 2.4 kg. So this is an absolute measure of dispersion. Okay. Now the next is, see, for the column xi minus x bar, some values were positive, some were negative. So one remedy you give that you have to consider the absolute value, and after that the problem gets solved. So is there any some thing different way by which we can identify whether here there will be no negative value. So another way is, if you consider xi minus x per column, you have to take square of that. So 3 square is 9, minus 5 square is 25, 1 square is 1, 2 square is 4, minus 1 square is 1 as such. So it will be, I think, 25 plus 9 is 34, 34 plus 6 is equal to 40. But what is this? Xi minus x bar square is nothing but square of the deviations of individual observations from their arithmetic mean. And if we take their arithmetic mean, so that will be, the formula will be summation of xi minus x bar to the power 2, I running from 1 to n upon n, and that will be 40 upon 5, and that will be equal to 8. And the name of this is variance, variance of x, variance of x. It is denoted by sigma square. So remember, so the next measure of dispersion is variance. So I am writing here variance. I can say variance as it is the arithmetic mean of the squares of the deviations of the individual observations from their mean, means arithmetic mean. Okay, so it is denoted by sigma square. And what about the unit? So if individual observations are unit kilogram, each of these xi minus x bar will have a kilogram square, so 40 kilogram square divided by 5 is unitless quantity, and 8 will be kilogram square. So it has some units, so this will be an absolute measure of dispersion. Then I'm going to come about, hey, so I know that I have to write the formula of this. I'll be writing, I'll be simplifying that formula also. Let me write the formula in case of raw data. Variance of x. Variance of x is equal to 1 upon n summation of xi minus x bar to the power 2, I running from 1 to n. Further, we can simplify this, and after simplification, we'll be getting this as 1 upon n.
Hello, sir.
Yes, please.
Sir, variance slide showत नाही सर, आधीची slide दिसायली.
Yes, yes, yes. I'm able to move, but I do not know why is it happening. So I will be stopping share, and then again. Okay, I'll skip, and then pointer pen, and this is black. Okay. I think we are able to see now. This is equal to, if we simplify this, then this will be 1 upon n summation of xi square. Computer and IT people have already studied this in their M3. Summation xi square upon n minus x bar to the power 2. So this is the formula of variance in case of raw data. I am going to write the formula in case of group data also, and I am going to derive the simplified form also. This is also very simple. You can quickly do this. Okay, here itself I'll be trying to do here quickly. Then I'll be doing the same thing, but before that, I have already told you that this is an absolute measure, so this is 1 upon n summation I from 1 to n xi to the power 2 minus twice xi into x bar plus x bar to the power 2. Then if we separate all these things, so 1 upon n summation of xi square I running from 1 to n minus 1 upon n is I'm doing some space, then summation I from 1 to n 2 into xi into x bar plus leave some space 1 upon n summation of I running from 1 to n x bar to the power 2 outside and 1 inside, so this is equal to 1 upon n summation xi square I running from 1 to n minus 2 times x bar into summation xi upon n is x bar into x bar is x square and plus x bar to the power 2. Then see summation 1 I from 1 to n is n upon n is equal to 1, and finally the answer is 1 upon n summation of xi square I running from 1 to n minus x bar to the power 2. So this is the formula for variance. I am going to explain the same thing in case of group data also immediately. So here okay, I'm not able to. No problem. Next slide. So here variance in case of grouped data. So this is xi minus x bar to the power 2. That is multiplied with fi summation over all the k classes I from 1 to k and divided by total number of observations capital N. And this is sigma square is the notation. So 1 upon capital N summation I from 1 to k fi times xi square minus twice xi into x bar plus x bar to the power 2 is equal to 1 upon n summation fi into xi to the power 2. This is the first term minus 1 upon capital N summation I from 1 to k, 2 outside, xi cannot be taken outside as I is the running variable, but x bar is only one for a given data, plus 1 upon capital N summation of fi I running from 1 to k, x bar square will be constant outside. So constant can be written outside or inside, it really doesn't matter. There is no change in term 1, and then minus 2 into x bar. We know that I missed here summation fi into xi. Huh? So this is summation fi into xi upon capital N, that is nothing but x bar plus x bar times summation fi means sum of all the frequencies, and that is n. N cancels, and this is x bar to the power 2. So that I am making some mistakes while writing, but I will be careful henceforth. So the simplified formula is 1 upon n summation of, this is xi square into fi. Square is only for xi and not to fi. And that is just multiplied with fi. Minus 2 times x bar square plus 1 times x bar square, that is x bar minus x bar to the power 2. So this is the formula, and I am not going to discuss about that moments, then skewness and cortices. Already you have studied that, but I want to tell you that there are 3 types of moments, that is moments about an arbitrary value, then raw moments, and moments about arithmetic mean, which are also called as central moments. Now there is some relationship, and this variance is nothing but second central moment, or the second moment about mean. This is mu2 variance. Okay. And what is the formula in case of this? And this is if you see the first term, summation fi into x square upon capital N, that is nothing but mu2 dash, means this is second raw moment minus, and let me tell you that x bar, formula of x bar is 1 upon capital N summation fi into xi. I from 1 to k, this is x bar. Okay, so this x bar is nothing but first raw moment, so which is mu1 dash and square of that. So this is the relation between central and raw moments, mu2 equal to mu2 dash minus mu1 dash to the power. Okay, so this is what I wanted to tell. Then let me go further here. So let us try to discuss one problem. Here I have picked randomly one problem few time back. And that is nothing but calculate mean, means arithmetic mean and standard deviation. Generally means it is arithmetic mean and standard deviation for the following table giving age distribution. But before that, let me complete. So whatever I was doing, so let me complete that, because I have discussed this variance. This variance is an absolute measure, and let me finish. There is one more measure, and that is, before telling that, I want to tell you that we have seen first measure of dispersion as range, then coefficient of range, then mean deviation about mean, then variance. After variance, what? So that is also important. So I'm going to discuss that here, probably fifth, and that is called as standard deviation. You have to remember that these topics are very, very important. Standard deviation is denoted by a sigma. Now, if you remember, just now we have seen, oh sorry, again I am in mobile, I am seeing the same screen. So again I stop share, and thanks, somebody had reminded me, so I am careful now. So now I think it is standard deviation. Okay, and before that we had seen variance, and we have written variance as sigma square, which is the arithmetic mean of squares of the deviations of individual observations from their arithmetic mean, that was denoted by sigma square. So you can understand that the square root of standard of variance is going to be the standard deviation. But I will be writing perfectly, because now I want to tell you one thing, that whatever the measures we have seen till now, such as range, coefficient of range, mean deviation about mean, variance, and now standard deviation, and one more is going to be seen by us. These are all 6 measures of dispersion or measures of variations. And that means deviation means farak, and we know that deviation or farak is never negative. If I ask you what is the difference between 2 and 5, you will answer 3. And if I ask what is the difference between 5 and 2, again the answer is 3. So absolutely it is absolute. Difference is always absolute. And thus any measure of dispersion will always have non-negative value. If you find range, coefficient of range, mean deviation of about mean, variance, standard deviation, and the next is coefficient of variation. For any data, at least it will be 0. And theoretically, 0 is possible, but practically, if you go, it is very less, absolutely no chance that you will find the value of any measure of dispersion as 0. And if you are wise enough and you have tremendous thinking capacity, then you will tell that yes, that there is some standard data, really ideal data. Suppose just consider there are only 5 observations and value of each observation is 10, 10, 10, 10, 10, 10, 10, 10. So already I have told you for such data, arithmetic mean, geometric mean, harmonic mean, median, and mode all will be exactly equal to 10. And for same data, range will be 0, coefficient of range 0, mean deviation about median 0, sorry, mean deviation about mean 0, then variance will be 0, standard deviation will be 0, and also coefficient of variation will be 0. Any measure of dispersion will be 0, and that is really ideal. It cannot be less than 0, and this ideal situation is going to happen only when all the observations in the data are exactly the same. And one more thing in relation to that, suppose if I have a particular data, I have evaluated variance of that, suppose it is coming as 25, then square root of 25 is plus 5 as well as minus 5. So we will not say that the standard deviation of that data is minus 5. Just now I have explained so many things in relation to that. So we have to say that the standard deviation is nothing but the positive square root of variance. Positive square root of variance, it is called as standard deviation. We already seen that if individual observations have unit kilogram, then standard deviation is, sorry, then variance is going to have unit kilogram square, and hence standard deviation will have unit kilogram. It is going to have some sort unit, so it is going to be an absolute measure. Wonderful. Now, step by step, we have improved from 1 to 5th, and finally we have reached to a very standard measure of dispersion or variation, and that is nothing but standard deviation. Yes. This is absolutely excellent as long as we have only one data set. Please listen me, it is really interesting. So we can always make any topic very much interesting if we try to relate some real life situations with some proper examples, and if the examples are very much concerned to you, then it will be really worth and wonderful also. So I also love cricket very much, and definitely uh, before the beginning I have told that how to identify whether a batsman is good or not. So one of the criteria is average. So yes, absolutely. Now actual cricket is test cricket, 5 days cricket, and then it came as 50-50 over ODI. That is called as ODI, one day international, means it is of 50 overs per inning, and then it is coming as 20-20. Just now it is 20. Let us say 20-20. It may happen that it may be even shorter form in coming days. So we do not know, but. So in this quick cricket, strike rate has been becoming very much vital. If there would have been Sachin Tendulkar or Rahul, not Sachin Tendulkar, Sunil Gavaskar, Rahul Dravid could not have done good in 2020. But there are some people who are like I from this KKR. So these people are doing excellent. But the in test cricket, the best criteria is average. Now, in relation to that, I want to talk about the next measure of dispersion. I have already told you that as long as there is only one data set, standard deviation is really a wonderful measure of dispersion. But whenever there is a discussion of two or more than two different data sets, is it really worth to find standard deviation of each of the data and compare? Absolutely not. Because for the same, I will like to share you some examples with you. Suppose there is one data, there may be 2000 observations, and each observation has unit kilogram. There is another data, there are 3000 observations, and each observation has unit centimeter. Now, my curiosity is that which is data between these two that has less variation among the individual observations from their average values. So if you just try to find standard deviation for both the data sets, suppose you find standard deviation of the first data, it will be some numeric value and it will have unit kilogram. If we find standard deviation for second data set, it will be some another numeric value and it will have unit centimeter. One has unit kilogram, another has unit centimeter. Is it you will agree that no, we cannot compare. This is not. These are not of the same level because we try to compare the things which are of the same level. Now it is very much obvious that suppose you are engineering student and I'm picking any one TE computer student and I'm going to compare that student with student from 10th class. So it is really meaningless. So the two people or entities should be at the same level. Then there is something uh, to be compared with each other. Otherwise not. So this is one example. Another I will like to tell you to understand the next formula in a better way. Now see friends, I want to ask you one question. Who is better batsman, either Sachin Tendulkar or Zaheer Khan? This is my question. Sachin Tendulkar or Zaheer Khan? Before that, again my question, I'm asking that question. What are the different criteria to call a batsman as a good batsman? So the first answer is average, second answer is strike rate. Then there is something another also. What can be that? I'm also thinking. Yes, average is should be nice. Strike rate should be nice. One more, one more word. I want to listen from you. Is there anyone who can share thoughts? That is very vital. Please, please contribute from your side. Average, strike rate, one more. Very important. If there is only one or two matches, there is nothing point. So, but suppose there are many matches, maybe a World Cup. In World Cup, we have to play a number of matches. If there is Sehwag, suppose in a match against Pakistan, he is hitting a century, and because out of that century, India is winning. So that is a thing of proud of for all. But in the next match, suppose against England, he is getting out of zero. So he is contributing nothing in the second match. Instead of that, we will like to have some batsman who will be. What is the name? What is the appropriate name for the same? Yes. I used to get the answer very much quickly every time in offline. Yes, anybody can unmute and tell me. Please. Consistency, yes, Omkar Kshirsagar, yes. Consistency, yes, that is the word. During every time I get this. Consistency. Consistency is very important. We have to be. Everybody likes to be consistent. Otherwise, suppose in the 12th examination, if you are scoring 95 in mathematics and you are scoring 32 in English, then 95 in mathematics is of no use. You have to pass. You have to pass at least every subject. Then only. So it is as compared to this student. If there is some student who is scoring 70 to 75 marks in all the subjects, it will be called as better. So consistency is very much important. So you will agree that okay, Sevak. Then during our teenage, there used to be Krishnamacharya Srikant along with Sunil Gavaskar. Both were exactly of opposite nature. One was very much systematic, technical batsman Sunil Gavaskar, and at the other end, there is no technique at all. There is only let the ball come and I'll hit let it go at any way. 4-6 or most on the most occasion 0. Krishnamacharya Srikant. He was engineer. There are so many cricketers who have been engineers. Sanil Kumble, Jawaharlal Srinath, and so many. Okay. So let me come to the point that if I want to compare this again, there is some problem in sharing. So what is happening? Quickly. Oh. So we are going to finish within 5 minutes. Please be connected. So I was talking about who is better batsman, Sachin Tendulkar or Jair Khan. Jair Khan is another uh, left hand seam bowler. He is actually he had taken admission for engineering B in Loni. That college is also affiliated to SPPU. Some years back, 15, 20 years back. But he could not complete engineering because he was concentrating more on cricket. So our very senior faculty colleague Tambe sir has shared some of his experiences, Jair Khan. But now here I want to tell. See, please.
हो हो ती पण पाहिजे आपल्याला मंडळाचा असेल मेन हा
So I think I will have to mute Priyanka. Okay. So I know that these things happens. So finally here, Sachin Tendulkar, he has played so many one-day matches, more than 450, and he had started with 0. If I know that I have seen his first match. I hope that all are listening to me. So in Pakistan, he was just merely around 16 or even less than 16 years of age. In that, before the one day series started, authentic, there will be one unauthentic match, show match, and in that India lost. Definitely India lost, but while chasing him, Tendulkar came as at position 6, and then he had hidden 3 consecutive sixes to the leg spinner Abdul Qadir. So I remember that, and he had scored 50 in just 17 to 18 balls. So that was really fabulous. And after that, he made one day debut, and in that match he scored. In the first match, he was out on 0. So definitely, some people used to say that मी 0 पासून सुरुवात केली आणि एवढं जग निर्माण केलं. तसंच आय थिंक दॅट सचिन तेंडुलकर मस्ट बी सेइंग आय हॅव स्टार्टेड विथ झिरो अँड आय हॅव क्रिएटेड दिस सिस्टम. So this is wonderful. Then his first century came in I think 89th or 90th match. So century and after that so many and one of the matches he had scored 200 plus. I think against South Africa and something like that. So many between zero and so many so 450 plus innings are there, and this is the raw data of that. We can find arithmetic mean. Arithmetic mean will be, I think that it is around 45, but I have not found the standard deviation. I do not know. This is in front of us. This data is in front of. Then Zair Khan. Zair Khan is another batsman. Sorry, he is bowler, left-hand bowler. He was an excellent bowler, and he has played some World Cups for us. Now, he might have played around 200 one-day matches, out of which he got opportunity on very less number of occasions, maybe 45 or 50 number of occasions to bat. And out of that, if you see score 6 or 2, 0, 7, 8, 11, something like that. So as long as somebody suggested very nice word consistency, so you will agree that Zair Khan is very much consistent as compared to Sachin Tendulkar. Tendulkar is not really reliable. So 0, 200, 100, 13, 78, absolutely not reliable. He is not consistent. So shall we say that Zair Khan is better batsman than Sachin Tendulkar? Absolutely not. So you told that this consistency word is very important. And here I try to explain, and you have agreed that yes, Zair Khan is seems more consistent than Sachin Tendulkar. So shall we call Zair Khan as a better batsman than Sachin Tendulkar? No, because his figures are small, and we have to take care of his standard deviation also. Yes, we have to find standard deviation of the first data. We have to find standard deviation of the second data. Here we have already found x1 bar as 45, x2 bar might be something around 7. Okay, so similarly find sigma 1, sigma 2, and then what we have to do here, sigma 1 upon x1 bar. So that figure will be something 0.178. So we have to multiply. It is a practice to multiply it by 100 and called is at a percentage. And here also sigma 2 upon x2 bar multiplied by 100, and that is called as percentage. And the name of this is coefficient of variation. Coefficient of variation for first data and coefficient variation for second data. Now we have taken care of standard deviation also. Definitely standard deviation of the first data will be very, very large as compared to the standard deviation of the second data. You can see because of the style in which the observations are varying. In the first data is much larger as compared to this. So sigma 1 is very, very large as compared to sigma 2. Simultaneously, we cannot forget average also. So the next formula is coefficient of variation. Coefficient of variation, CV, and CV is found as standard deviation divided by arithmetic mean multiplied by 100, and that is in percentage. I have already told that any measure of dispersion will always have a non-negative value. I do not say that positive. Yes, on 99.99% of occasions it will be positive, but if our data is really very ideal, so in that case any measure of dispersion will have value 0. So I am taking care, I am not ignoring that situation also, and hence I am saying that the numeric value of any measure of dispersion will always be non-negative. And here we have written the formula of coefficient of variation. We know that 100 is non-negative quantity. Actually, it is positive natural number. standard deviation, we have seen the positive square root of variance, so it is guarantee. It is also non-negative, but we cannot guarantee that arithmetic mean will be always positive. So just make absolute value, and this is the formula, coefficient of variation. So whenever we have, before that, relative or absolute, we know that if individual observations have unit kilogram, then standard deviation will have unit kilogram, arithmetic mean will have unit kilogram, kilogram cancels, and this is going to be a relative measure, of dispersion. So the relative is important. That's why even if the individual observations have some unit, data 1 may have unit kilogram, data 2 may have unit centimeter. If we find coefficients of variation for both, those will be unitless quantity. Those are brought at the same level. Now, yes, you can compare. Then see which is that data for which there is less value of coefficient of variation. That data will be more consistent. So why not more than 2? There can be 2, 3, 4. You may consider 10 different data sets. Find coefficient of variation for each of these, and that data which has the least value of coefficient of variation is going to be the most consistent data among all the different data sets. So this is the power of coefficient of variation. So with this, I would like to stop. I think it is my always endeavor to discuss for at least 60 minutes, yes, because whenever I am going to say that I have taken, I will not be less, I will be always more. So here I stop recording. It is